this lesson, we're going to talk about division of polynomials. So what I am dividing is called my dividend. The number or the polynomial that I'm dividing by is called my divisor. What I get in the end is my quotient. And then if I have a remainder, then I would put that remainder over the divisor. So we're going to start with long division. Long division works on all of the polynomials, and then we'll talk about synthetic division, which only works when you're dividing by a linear factor. So what I am dividing by is going to go on the outside, and then I'm going to put what I am dividing into on the inside. Now this works just like regular division. First you're going to divide, but you're going to divide the first terms. So the first term on the inside with the first term on the outside. Then you're going to multiply. Then you will subtract. And then you're going to drop another term or two terms depending on how many terms you need to drop. So first things first, I'm going to start with the x to the third, and I'm going to divide that by x. All right, so we have x to the third divided by x, which is x squared. That's going to go on top. Remember, when you divide those two, the number always goes on top there. Then you're going to multiply. So I have to take this x to the third and distribute it to both of the terms on the outside here. So x to the second times x is x to the third. And then x to the second times 3 is 3x to the second. Now I'm going to subtract. So it's easier for me, and maybe easier for you too, to just go ahead and change these signs. So if this is positive, now it's negative, and if this is positive, now it's negative. I'm subtracting them. So I have x to the third minus x to the third, which should be 0. That should always cancel out. And then I have 5x squared minus 3x squared, which is 2x squared. Now, you always want to make sure that your like terms are adding up. So like my x to the thirds were adding up, and my x to the seconds were adding up. All right, I have one term now. But because I have two terms out here, I need to have two terms in here. So I'm going to drop the positive 6x. And now I have two terms. I'm going to go ahead and divide again. So now I have 2x squared divided by x. So 2x squared divided by x. That gives me 2x. That is going to go back here. So 2x times x is 2x squared, and 2x times 3 is 6x. So after I multiply, then I'm going to subtract. So this is positive, now it's negative. This is positive, now it's negative. And I'm going to combine these. So 2x squared minus 2x squared is 0. 6x minus 6x is also 0. And then I'm going to drop, but the only thing I have left to drop is a 9. If I don't have two terms, I can't divide again. So this is my remainder. So my answer would be what I have on top, the x squared plus 2x. That's what I got when I divided. All right, that's my quotient. Plus, since this is positive, I'm going to put a plus, 9 over, and then what you divided by, which is the x plus 3. Now, if it doesn't divide evenly, that means that x plus 3, not a factor of x to the third plus 5x squared plus 6x plus 9. All right, if you're looking at it and you get a remainder of 0, if you don't have a remainder, that means that it is a factor. Okay, just like if I take 6 divided by 2, I get 3. It divides evenly, so I know 3 is a factor. I also know that 2 is a factor. All right, number 2. This time we are dividing by 4x squared minus 6x plus 9. Now, if you'll look up here at your dividend, all right, I am missing a bunch of terms. Now, I may not need them. Sometimes until you start dividing, you don't know if you actually need those terms for it to line up. But I'm going to put them in there. So since I started with 8x to the third, I'm going to go ahead and put a 0x squared as a placeholder and a 0x since I'm missing both of those, and then I have that 27. All right, so I'm going to take the first term underneath and divide it by the first term on the outside. 8x to the third divided by 4x to the second is 2x. That goes on the top. Then I multiply 2x times 4x squared is 8x to the third. 2x times negative 6x is negative 12x to the second. All right, so I did need that placeholder so that my terms would line up. All right, and then 2x times 9 is 18x. And again, I have like terms here. So now that I've got that, I need to subtract. So 8 becomes negative, 12 becomes positive, and 18 becomes negative. So 8x to the third minus 8x to the third is 0. 0x squared plus 12x squared is 12x squared. 0 minus 18 gives me negative 18x. And I have two terms, but if I want to divide again, I need to have 1, 2, 3 terms. So I'm going to drop the positive 27. I now have 3 terms, and I can divide again. So 12x squared divided by 4x squared. That gives me 3. So plus 3. Then I multiply. 3 times 4x squared is 12x squared. 3 times negative 6x is negative 18x. And 3 times 9 is 27. Now I'm ready to subtract. So 12 is now negative, 18 is now positive, 27 is now negative, and all 3 of these cancel, which means I have a remainder of 0. What that means is that 4x squared minus 6x plus 9 is a factor of 8x to the third plus 27. So my answer is 2x plus 3, and I don't have a remainder, so that is just my answer. Number 3, I'm dividing by x squared minus 4x plus 3, so that's going to go on the outside. On the inside, this should be x to the second. I am not missing any of the terms, so I've got x to the third minus 6x to the second plus 11x minus 6. I'm going to start by dividing the first term underneath by the first term on the outside. X to the third divided by x to the second is x. X times x squared is x to the third. X times negative 4x is negative 4x squared. And x times 3 is 3x. Now I will subtract. So this becomes negative, the 4 becomes positive, and the 3 becomes negative. All right, x to the third minus x to the third is 0. Negative 6x squared plus 4x squared is negative 2x squared. 11x minus 3 is 8x. And I have 3 terms outside, which means I need 3 terms here, so I drop the negative 6 and I divide again. Negative 2x squared divided by x squared. That gives me negative 2. And then I multiply. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is positive 8x. And negative 2 times 3 is negative 6. Now I'm ready to subtract. So 2 becomes positive, 8 becomes negative, 6 becomes positive, and all of these cancel again, leaving me with a remainder of 0. That means that x squared minus 4x plus 3 is a factor of x to the third minus 6x to the second plus 11x minus 6. So my answer after I divide them is x minus 2. All right, number 4. We are dividing by 4x squared plus 9. Now, I'm missing some terms there, but I'm not going to put them in there. And I'm missing some terms on my dividend. I'm not going to need them all. However, I'm going to put them in here as placeholders because I do need one of them. I just don't need all of them. So I'm missing 3 terms, so I'm going to go ahead and put all 3. If you don't need it, then you don't have to worry about it. You can just skip over it when you continue on. All right, so I have 16x to the 4th divided by 4x to the 2nd. 16x to the 4th divided by 4x to the 2nd is 4x to the 2nd. 4x squared times 4x squared is 16x to the 4th. And 4x squared times 9 is 36x squared. So I don't have an x to the 3rd. I'm just going to ignore that one. But I am going to line up my 36x squared with its like term of 0x squared. Now I subtract. So 16 becomes negative and 36 also becomes negative. This one cancels. 0 minus 36 is negative 36x squared. And I don't think I'm going to need the 0x. I think I'm going to need the negative 85. But I do know I have another term that I can pull down. So I know I have 2 that I can go ahead and divide with. So I'm going to not pull one down yet and just see what happens when I do my division, and I'll pull down the one that I need. So negative 36x squared divided by 4x squared. That's going to give me negative 9. Then we multiply. Negative 9 times 4x squared is negative 36x squared. And negative 9 times 9 is negative 81. So I don't need this. I need the negative 85. All right, and then I have negative 81. Subtract. So this becomes positive. This becomes positive. These two cancel. Negative 85 plus 81 is negative 4. So I have a remainder, which means 4x squared plus 9 is not a factor of 16x to the 4th minus 85. So my answer would be 4x squared minus 9. And then I have a negative remainder, so minus 4 over what I divided by, which was the 4x squared plus 9. Okay, let's talk about synthetic division. Now, you can only use synthetic division when dividing by a linear factor. Now remember, you're going to know if it's a linear factor if the degree of your binomial is 1. For instance, right here, I'm dividing by a linear factor because my degree is 1. So you're going to take what you're dividing by, and you're going to set it equal to 0, and you're going to solve. So in that case, I get 3. That's going to go on the outside of a box that requires about 2 lines of work here. Now you're going to take all the coefficients of what's inside. Okay, now if you're missing any terms after starting with your largest, you have to put a 0 in its place. So for instance, I started with x to the 3rd. There's a 2 in front of that. Then I have x to the 2nd. We have a negative 7 there. But I don't have an x term, an x to the 1st. So there needs to be a 0 in that place. And then I have my number without the variable that also always has to be there. So I'm going to drop the 2. Okay, always drop the first one inside the box. And I'm going to multiply it by the 3 on the outside. So 2 times 3 is 6. That is going to go in this next little slot. Then I have negative 7 plus 6 is negative 1. And then I take that times the 3. And that goes here. So negative 3. Then I'm going to add down. 0 and negative 3 make negative 3. Then I take that times the number on the outside. 3 times negative 3 is negative 9. And I have negative 4 and negative 9, which makes negative 13. that is going to be my remainder. Now, when I divide things, like for instance, if you look at number 4, I took an x to the 4th and I divided it by something with a degree of 2, which means my outcome is going to be whatever those degrees subtracted is, because I'm cutting it down. So if I had x to the 4th, I divided by x to the 2nd, my answer is going to have a degree of 2, because 4 minus 2 is 2. So if you look here, I am taking an x to the 3rd and dividing it by an x to the 1st. 3 minus 1 is 2. So this is going to have a degree of 2, which means 2 is going to go with the x squared, because this has a degree of 2. The next term, negative 1, will go with the x, so negative x. The next term is the term that doesn't have an x, so my constant was negative 3. And then I have my remainder. It's negative, so minus 13 over what I divided by, which is x minus 3. It's really a short way of doing things. Now, you could do long division on that. However, it's shorter to do it this way. All right, we are dividing by x minus 1, so I set x minus 1 equal to 0. This is a linear factor, so I can do this. That gives me a 1. 1 goes on the outside of a box. Now, if I look up here, I have x to the 3rd is my biggest degree. I am missing x to the 2nd, so when I put my coefficients in here, I have 3, and then I needed a 0 right there to replace that x to the 2nd. Minus 5, and then 10. So I drop the 3. Then I multiply 3 times that 1 on the outside. 3 times 1 is 3, and then I add down. 0 plus 3 is 3. Then I multiply. 3 times the 1 on the outside is 3. Then I add down. Negative 5 plus 3 is negative 2. Then I multiply times the 1 on the outside. Negative 2 times 1 is negative 2. Then I add 10, which gives me a remainder of 8. I started with x to the 3rd. I divided by an x to the 1st. So 3 minus 1 is 2. This will have a degree of 2. So 3x to the 2nd. The next 3 goes with my x, so plus 3x. Then I have my number without the variable, my constant, so negative 2. And then my remainder is a positive 8, so plus 8 over what I divided by, which was x minus 1. All right, I'm dividing by x minus 2, so I set the x minus 2 equal to 0 and solve. So the number on the outside of my box is a 2. I am not missing any terms up here. So I have a 1 in front of my x squared, a 7, or 1 in front of my x cubed, a 7 in front of my x squared, a negative 26 in front of my x, and a 17 without a variable. So I'm going to drop the first number in the box and multiply it times the 2 on the outside. 2 times 1 is 2. 7 and 2 make 9. 9 times 2 is 18. Negative 26 plus 18 is negative 8. Negative 8 times 2 is negative 16. Plus 17 is 1. Since I started with x to the 3rd and I divided by x to the 1st, my degree of the outcome is x to the 2nd. So 1x to the 2nd plus 9x minus 8, and then plus my remainder, 1 over what I divided by, which is x minus 2. All right, the remainder theorem states, sorry, I have some grammatical errors here, that if a polynomial p of x is divided by x minus a, then the remainder is p of a. That just literally means if I took this number behind the minus sign and I plugged it into my polynomial, I would get the remainder of what I divided. So, like if you look at number 7, it's saying that if I were to take 2, which is what is on the outside here, and plug it in for all of the x's, I'm going to get 1 as the answer. So I have done this. All right, I went and plugged in 2 for everything. Substitution, I substituted 2 in, and I got 1 as an outcome. All right? The factor theorem states that the expression x minus a is a factor of the polynomial if and only if, when you plug in that number, you get 0. In other words, the remainder is 0. So we're going to use synthetic division to show that the remainder of p of x, when it's divided by x plus 5, is equal to, and again, lots of typos, I'm sorry, p of negative 5. So if I took x plus 5, set that equal to 0, and solved, I would have x equals negative 5. That's why they're saying if I plug negative 5 in, I'm going to get what the remainder is. Okay? So we're going to put the negative 5 on the outside of the box. And I'm not missing any terms, so I have a 1, 10, 29, 24. I'm going to drop the 1. 1 times negative 5 is negative 5, plus 10 is 5, times negative 5 is negative 25, plus 29 is 4, times negative 5 is negative 20, which gives me a remainder of 4. Now, I'm supposed to be proving that if I plug negative 5 in for all of the x's, that I'm going to get 4. So let's do that. If I plug in negative 5 to the third plus 10 times negative 5 squared plus 29 times negative 5 plus 24. If you do all of that, you're going to get 4. It should match that remainder right there. Now, here's the deal. I myself am not gifted enough to plug in negative 5 and do all of this in my head. However, I did not need a calculator for this. So if I was ever in need of doing math without a calculator, I would be able to do this by using synthetic division. Now remember, this only works on linear factors. All right. For the polynomial f of x equals x squared plus 8x squared, x cubed plus 8x squared plus 12x plus 5, and that should be x equals negative 2, find f of, and again, that should be negative 2. Sorry, guys. By direct substitution and by the remainder theorem. So let's start with direct substitution. I'm literally going to take that negative 2 and plug it in to my function. So I have negative 2 to the third plus 8 times negative 2 squared plus 12 times negative 2 plus 5. Now if I plug that in, you can see I've plugged it in here. I'm going to get 5. That tells me that the remainder I'm going to get when I do the remainder theorem is going to be 5. So I'm going to put the negative 2 on the outside of the box. I am not missing any terms, so I have a 1, 8, 12, and 5. I drop the 1. 1 times negative 2 is negative 2, plus 8 is 6, times negative 2 is negative 12, plus 12 is 0, times negative 2 is 0, with a remainder of 5. All right, now we're going to use synthetic division and the factor theorem to determine if our linear factor is a factor of p of x. So to prove that, I'm just going to set my binomial here equal to 0 to get that number that's going to go on the outside. So I know that 6 is going on the outside. I'm not missing any terms. I have an x to the fourth, and then after that I have x to the third, x to the second, x, and then no x. So I have 1, negative 8, 16, negative 23, and negative 6. So I drop the 1. 1 times 6 is 6, plus negative 8 is negative 2. Times 6 is negative 12, plus 16 is 4. 6 times 4 is 24, plus negative 23 is 1. And 1 times 6 is 6, with a remainder of 0. So if I get a remainder of 0, that means that x minus 6 is a factor of my p of x. If I got a number here that was something other than 0, then it would be a no. So yes, This is a factor. All right, so the number on the outside will be a 4. Again, not missing anything. So I have 1, negative 10, 28, negative 16. I drop the 1. 4 times 1 is 4, plus negative 10 is negative 6. Negative 6 times 4 is negative 24, plus 28 is 4. 4 times 4 is 16, plus negative 16 is 0. Since I got a remainder of 0, yes, x minus 4 is a factor.